So in the last lecture, we have seen the electric field intensity in a coaxial cable and the electric potential due to the different type of charges. And we have seen the potential gradient. Once if you know the electric field intensity to find potential. And similarly, if you know the potential to determine what is the electric field intensity, both we have seen. And we have seen the concept of the electric dipole. And you already know the electric field intensity due to the electric dipole. From there, we have already derived the electric potential also. So all these topics has been discussed in the last class. So now we will try to discuss the problems related to this. So see the first question and read it. So there is a coaxial cable having a physical length of 50 centimeters and an inner radius of 1 mm and outer radius of 4 mm. The space between the conductors is assumed to be filled with air. The total charge on the inner conductor is 30 nanocoulombs. Then the charge density on each conductor and the electric field intensity between the conductors will be. So you can try to put it in a diagram. So this is a coaxial cable. So first thing, the length of the coaxial cable here he given 50 centimeter. And consider A is the inner conductor radius and B is the outer conductor radius. So in the question he has given A is equal to 1 mm and B is equal to 4 mm. The space between the conductor is filled with air, you can say. And the total charge on the inner conductor he has given 30 nanocoulombs. So straight away he has given the total charge on the inner conductor is equal to 30 nanocoulombs. So what will be the total charge on the outer conductor? We know that the charge on the outer conductor is minus of the charge on inner conductor. So the outer conductor is having a charge of minus 30 nanocoulomb. So when you see the charge on inner conductor, that is equal to the charge density on the inner conductor into the surface area. That will be 2 pi. A is the radius and L is the length of the coaxial cable. So from this you can find out the value of rho s inner. So you can get rho s inner is equal to 30 into 10 power minus 9 divided by 2 pi. So radius of inner conductor is 1 mm 10 power minus 3 and L is 50 centimeter. So you can simplify this value. So I was directly writing the value here. Everybody can cross check that. This value will be 9.5 microcoulombs per meter square. You can cross check that also. And similarly, the charge on outer conductor minus 30 nanocoulomb is equal to the charge density on outer conductor into 2 pi BL. B is the radius of outer conductor and L is the length of coaxial cable. So you can find out the charge density on the outer conductor is equal to minus 30 into 10 power minus 9 divided by 2 pi. So B is 4 into 10 power minus 3 and L is 50 into 10 power minus 2. You can simplify the value. And this you can verify, you will get the value as minus 2.39 microcoulombs per meter square. So that's what we have seen. The charge can remain same on inner conductor and outer conductor. Whereas if you see the charge density, that will not be same. And at the same time, you can use the other formula here. The rho s outer equal to minus rho s inner into A by B. So we will get the same value here. And in the question, he's asking one more thing. Find the electric field intensity between the conductors also. So in the last lecture, we already seen between the electric conductors, what is the electric field intensity. So we have seen the value will be rho s inner into A by rho divided by epsilon is epsilon naught here. So you know the value of rho s inner and you know the value of epsilon naught, that is 1 by 36 pi into 10 power minus 9, and A is 1 meter, 1 mm, and rho you can take it as rho only. So leave it like that. So finally substitute the value and you will get the answer as 1079 divided by rho volts per meter. So you can cross check after that once you have the time. So any questions here we will discuss. The calculation part you can do it and please cross check that whether it is correct or not. So if you have any questions, you can reply in the chat box. So if you don't have any questions, you can reply here.
So the
So I
Royce
will move
outer
on.
will be given options like negative, or
Yeah,
it's
correct.
only okay.
Yeah, exactly. It depends on if the inner conductor is having a positive charge, the reverse outer will be obviously comes negative, right?
Yes, sir.
It depends on that, right? So we'll move on to the next question then. So see here, find the total work done in moving a charge of 2 coulombs from 6 comma minus 10 to 3 comma 4 comma minus 5 along a straight line in the electric field intensity. He has given this equation. So you need to find out how work done you need to do in order to move a charge of 2 coulombs in the presence of this electric field. So in the last class, we already seen when we are discussing the electric potential concept. So the total work done in order to move a charge in the presence of electric field is given by minus qt into integral E dot dl, where you can do the integration from initial point to the final point. So here initial point is 6, 8 minus 10 and final point is 3, 4 minus 5. So first of all, you already know the value of electric field intensity here. So you can say E is equal to minus x ax cap plus y ay cap minus z az cap. And what will be the displacement vector? You can see here, when you are moving from this point to this particular point, there is change in x happened, change in y happened, change in z happened. So the differential length can be written as dx ax cap plus dy ay cap plus dz az cap. So what is E dot dl here in this case? You can directly take the dot product here. So ax dot ax component will be 1. So the first term will be minus x dx and second term will be y dy and the third term will be minus z dz. Now you have to take the integration for this E dot dl multiply with qt. So what is the value of w you will get now? Minus 2 into, I can separate the integration, minus x into dx from 6 to 3. So integration y to y dy from 8 to 4 plus integral minus z into dz from minus 10 to minus 5. So you can do the integration and tell me the answer. Do the integration and post the answers in the chat. So everywhere when you do the integration, there will be 1 by 2, x square by 2, y square by 2, z square by 2. So I was writing that 1 by 2 as a common and minus 1. And integration of x will be x square, right? So x square subjected to 6 to 3 plus this will be y square subjected to 8 to 4 plus this will be minus 1 into z square from minus 10 to minus 5. So the total work done will be, so this will be minus 1 into, so here 9 minus 36, you will get minus 27, plus this is 16 minus 64, which will be minus 48, plus minus 1 into, this will be 25 minus 100, so which will be minus 75. So you can simplify the value. Minus 1 into, first one will be 27 minus 48 plus 75. So you can find out what is the value. So you can verify, you are getting almost like minus 54 joules. Yeah, correct. So in this case, you are getting work done is negative. What do you mean by that in that case? Are you moving in the same direction of electric field, or you are moving against to the electric field direction? Against. So everybody is saying against. No, 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 no. You can see this equation. So the total work done will be minus qt into integral E dot dl, right? So qt is a positive number here, right? So when qt is positive means the work done becomes negative if your E dot dl becomes positive, right? So your qt is already positive. So the work done becomes negative whenever you are moving in the same direction of electric field, right? So it is something like this. Suppose if the wind is flowing in a particular direction and you are also trying to move in the same direction, right? So in that case, your work done becomes negative because the wind itself does the job. So similarly, if you want to move the charge in the same direction of electric field, you will get the work done is negative because of this sign. So the moment work done is negative, which represents, so when I say the work done is negative, which represents the test charge is moving in the same direction of electric field. So you got the point here?
Sir, but that minus sign is applied because we are moving the test charge, means minus E dot dl, that potential we calculate.
Hmm.
That we do by moving it against the electric field, right?
Correct.
Uh,
No, that's
so that's
what,
why we
right?
had.
So what is that work done means you need to do some external work done in order to avoid whatever the Lorentz force is existing there. Right now, you are getting your work done itself is negative means what is the meaning of that? If it is work done positive means you have done some work intentionally. If the work done itself is negative means you are not doing the job. Whatever the field, whichever is existing, that itself does the job, right?
Okay.
So it is a simple example I have given. Suppose if the wind is flowing in a particular direction, you also just stand in that same direction. So what will happen? Whether you
Okay.
need to do any work in order to move in the direction of the wind, automatically the force which is existing itself does the job, right?
Okay.
So in that case, what actually have done? You have not done any external work done, and the existing force itself has uh, ensuring that you are moving in a particular direction. So you are moving a finite distance there, but that time the work done is done by the field. So you got the
Okay.
point now? Yeah,
Yes, sir.
right. So similarly, since the test charge is moving in the same direction of electric field here, because of this negative sign, the work done is negative. So which means that whatever the existing force itself is making sure that the charge can be moved in the direction of electric field. So move to the next question. So if the electric field intensity is given by, so this is a vector, then find the potential difference between the points. So this is your first point and this is your second point. So you know the electric field intensity, calculate the potential difference. So we already know the potential difference between x and y in this case is equal to minus integral E dot dl. So as per the definition in the last class, I told you The first subscript indicates the final point and the second one represents the initial point. So you need to take the integration from y to x. So y is the initial point and x is the final point. And you know the vector E, so you can straight away write down like this: x ax cap plus y ay cap plus z az cap. And what will be the dl vector in this case? So similarly, you can see here there is a change in x to y, there is a change in x, y and z. All the direction the variation happened. So dx ax cap plus dy ay cap plus dz az cap. So take the dot product and you can integrate. So the potential difference between x and y is equal to -1 into integration of E dot dl will be x dx. So similarly, you will get y dy plus z dz. So when you are substituting the x limits, it is from y to x. You need to keep remember that. So that will be 1 to 2 and 2 to 0 and 3 to 0. So you can calculate and post the answers in the group. So the potential difference xy is equal to -1 into, so everywhere 1 by 2 is there, take it common. So this will be x square from 1 to 2 and y square from 2 to 0 and z square from 3 to 0. So what is the potential difference you are getting right now? -1 by 2 into, so that will be 4 minus 1, it will be 3 plus 0 minus 4 plus 0 minus 9. So what is the value you will get? -1 by 2 into, so this will be, you will get -10. So you are getting Vxy is equal to 5 volts. Correct. So are you comfortable with the potential calculations right now? Potential and the external work done? Okay. So let's move on to the next question. So there is an infinite line charge. You can say, you can correct it. It is an infinite line charge having a charge density of 6 nanocoulomb per meter is located at x is equal to 0, 3, comma y equal to 0 in the free space. Then find the electric potential at 6, comma 0, comma 0. So we have seen in the previous lecture what will be the electric potential due to infinite line charge. You can apply the same formula. So before applying, you try to represent the given line charge in the diagram. So you can see here in the question, x is fixed, x is equal to 3 and y is equal to 0. So whichever is varying right now is nothing but the z, because he given x is a constant and y is a constant here. So the value of z changes. So the line charge is definitely parallel to the z axis. So the point is very clear. The line charge will be definitely parallel to the z axis, and at the same time it lies in the y equal to 0 plane. So y is equal to 0 plane means it's an xz plane. You can see here, this is xz plane. So line charge has to be placed in xz plane and should be parallel to z axis. So that's what I have represented here. And what is the meaning of this? This x is equal to 3 represents the line charge is at a distance of 3 meters from the yz plane. So this distance is nothing but 3 meters. And where you need to electric potential. So the electric potential you have to find on the x-axis itself at 6, 0, 0. So let us say this is the point 6, 0, 0. So can you tell me what is the radial distance here between the line charge and the observer? Good. It will be 3. So from the line charge to the observer, there is a distance of 3. So your rho value will be 3 straight away. So you can apply the formula right now. So the potential due to an infinite line charge is given by rho L by 2 pi epsilon into ln of 1 by rho. So this is the formula. You can, everything is given, you can substitute. So rho L is 6 into 10 power minus 9 and 2 pi. Epsilon is 1 over 36 pi into 10 power minus 9 because of free space. And ln of 1 by rho will be 3. So you can do the simplification and tell me the answer. So you can do the calculation. Everybody use the calculators if you have. And cross check this, you are going to get negative because ln of 1 by 3 is negative. So you are going to get minus 118.65. Please cross check the answer. So cross check the answer. Yeah. So it's right away a formula based question. So move on to the next question then. So the potential distribution in the xy plane is given by V is equal to 2x square plus 3y for all values of x and y. Then find the electric field intensity at minus 2 comma 0. So here in this question, the potential has been given. You have been asked to find out the electric field intensity. So once if you know the potential, what will be the electric field intensity? We have seen in the concept of potential gradient. So if you know the potential, to find out the electric field intensity, it is the negative of the gradient of the potential. So find the gradient of the potential and apply the negative sign. So what will happen? E is equal to minus 1 into, to find the gradient, you know that there is a rate of change in x happen into ax cap, and there is a rate of change in y into ay cap, and you can ignore the z contribution because he has given only in the xy plane. So this value will be minus 1 into, so differentiation of v with respect to x, get 4x into ax cap, plus differentiation of v with respect to y, you will get 3 ay cap. So this is electric field intensity, but you have been asked to find out at x is equal to minus 2 and y is equal to 0. So substitute that. So you will get electric field intensity, replace x with minus 2 and remaining terms as it is. So finally, what is the answer you are going to get? So here minus 8 and minus 1. So we'll get 8 ax cap minus 3 ay cap. So this is the electric field intensity. So any questions you can post here. So is it clear now, this question? Yes. So next question. So find the electric potential due to an electric dipole having a dipole moment of this one. He is given some value. And we know, you can see here, dipole moment is having the units of coulomb into meter. So you need to find the electric potential at 2, 3, 4 and assume that dipole is located along z-axis and centered at origin. So there is a dipole which is located along the z-axis and it is centered at origin. So this is your position 0, 0, 0 and this is z-axis. So you have been asked to find out the electric potential at 2, 3, 4. This is your observer position. So this is your radial vector, right? From source to observer, you are going to get a radial vector. So in the last class, we already seen the expression for the electric potential due to a dipole. So that is given by, in terms of dipole moment, so P dot AR cap divided by 4 pi epsilon into R square. So here what is AR cap represents? The unit vector along this R bar direction. So this is given by your unit vector. So if we substitute that, we know that the unit vector can be written as the original vector divided by the modulus. So R bar by mod R bar, here already R square is there. So I can call it as mod R whole cube. This is because AR cap can be written as R bar by mod R bar. So you can use this equation to find out the electric potential. So first of all, you know what is the value of P here is given 3ax cap minus 2ay cap plus az cap. Nanocoulomb into meter means 10 power minus 9 you can say. And the vector R bar can be written as the end point minus initial point. So 2, 3, 4 minus 0, 0, 0. So we will get straight away 2ax cap plus 3ay cap plus 4az cap. And what is the modulus of R here right now? So we can say root over 4 plus 9 plus 16. So you will get 29 power 1 by 2. So you can directly substitute in the potential equation right now. So V is equal to, so the dipole moment will be 3ax cap minus 2ay cap plus az cap into 10 power minus 9 into R bar will be 2ax cap plus 3ay cap plus 4az cap divided by 4 pi. So epsilon you can consider it as epsilon naught because the medium has not mentioned here. So you can assume it as a free space permittivity. And mod R whole cube means 29 power 3 by 2. So you can take time and you can simplify, and what is the value you can post it in the group. You can simplify it and tell me the answers. Zero 0.922. Now you can cross check it once again. 0.23, correct. 0.23 is correct. So this 3 into 2 and minus 2 into 3, this 2 you will get 0, right? So you will get straight away 5 gets cancelled. So finally, so 36 divided by 29 power 3 by 2 you will get. Cross check that. So you will get 0.23. You can cross check it if any calculation mistake if you have done. Once. So we'll go to the next question then. So the electric field on a plane is described by its potential. So he has given V equal to 20 into R power minus 1 plus R power minus 2. So where R is the distance from the source. Then the electric field is basically due to, is it due to monopole, dipole, or both monopole and dipole, or quadrupole? So can you answer this question? So here he given the expression for the potential. You need to say whether it is due to monopole or dipole or both or quadrupole. So first of all, we know, suppose if we have only one monopole like a point charge, what will be the potential? V is equal to Q by 4 pi epsilon into R, right? So in this case, the potential is proportional to 1 by R if it is one monopole. So in the case of a dipole also we have seen what is the electric potential. If you see the equation, I have given something like this, QD cos theta by 4 pi epsilon into R square. So for a dipole, the potential is proportional to 1 by R square. Right. Now if you see here, the same thing you can separate it. So 20 into 1 by R plus 20 into 1 by R square. So you can see here, the first term is 1 by R term. So it is due to monopole. And the second term is 1 by R square term. So it is due to dipole. So the resultant potential is the contribution of both monopole and dipole. The answer is both monopole and. So if we have only one charge, the potential is proportional to 1 by R power 1. If you have a dipole where two charges are located, potential proportional to 1 by R square. So hence R power minus 1 is due to monopole and R power minus 2 is due to dipole. So that's it. That is a questions part for the previous topic. And if you have any questions, you can try to clarify now.